Today we will talk about the last topic in our course, which is plate tectonics. To know what does it mean, plate tectonics, it's a theory. It allows us to explain many processes geologically, particularly with anything related to the Earth's surface or near to the Earth's surface, like from 0 to 100 kilometers. It's also a concept makes us understand how these processes operate. So it is just like a theory to explain the geologic processes within the surface or near to the surface of the Earth. Okay. In the past, people think about like the geologic processes were observed, we see them, but we don't know the causes that make them happen. For example, why do mountain belts occur where and when they do? Why they are here? And why they occur in this manner? So plate tectonics theory gives us a picture by trying to gather many different processes. The map that shows the current location of the continents and the suggestions of like moving where they were before, and you see those red arrows either converting or diverting. So the evidence or the evidences for plate tectonics are many actually. Let's talk about the first one, that not only the shapes of continents match up, as we said before, but also their geology. It's not only the borders. If you get rock samples from these continents, they are like the separated continents, you will find the same mineral and chemical composition of those rocks. Also, similar rocks and structures now separated by oceans, they line up if you put the continents back to their original location. Also, fossils of the same land animals are found in different continents, now thousands of miles apart, but they are the same fossils. For example, if you find fossils in west of Africa, you see the same fossils or almost the same fossils in the east of South America. Glaciers also occurred in areas now near equators. Tropical forests occurred in lands now near poles. So when continents come back together, glaciated areas now at poles and tropical forests now near equators. These are very strong evidences. Also, we were surprised that we can tell that the oceans are young, less than 200 million years, as compared to continents. So continents are older than oceans. And rocks get older as you move away from the mid-ocean ridges. Mid-ocean ridge is the area in the middle. If you see the floor, the ocean floor, the area in the middle, you see the magma coming out of this, as you see from this picture, and they travel away from apart from each other. We call it MOR, or mid-ocean ridges. And also ocean floor, it's found that 99% of the ocean floor is composed of basalt. also magnetic stripping, as you see from the picture on the right of the sea floor. Iron bearing minerals and rocks become magnetically aligned when the temperature falls below the Curie point, which is 500 to 800 degrees, from 80 to 500 degrees. Okay. Also, which is called apparent polar wander, APW, from the paleomagnetism science. The continent shows either poles have moved or continents have moved relative to each other. But since not all APWs show the same motion, poles are not moving, but continents are moving. Also, another evidence, the earthquake and volcanoes. They are concentrated in specific belts. Those belts, you know, those areas or those zones are the boundaries of the plates where all the relative motions is taking place. Here you can see the beneath subduction zone where the oceanic crust sinks underneath another oceanic or underneath a continental crust, and you can tell that most earthquakes are shallow, less than 100 kilometers in depth. However, all places where the earthquake go very deep, like 700 kilometers, we call them beneath zone, where the plates are moving back down or subducted into the mantle. Okay, now we come to the modern plate tectonic theory. We have to know three components, main components of the Earth. First one is lithosphere, which is solid, rigid plates, and they form, or it forms outer shell of the Earth. And two types of lithosphere: continental, about like from 100 to 150 kilometers in thickness, and oceanic, which is about from 50 to 100 kilometers in thickness. And both include uppermost mantle. Okay, so this is the first component. Second is a ionosphere, and it's from 50 to 150 kilometers to about 500 kilometers in thickness, as you can see from the picture, and partially molten, therefore low in strength, and layer over which the ionosphere is layer over which lithosphere slides. Oceanic lithosphere created at mid-oceanic ridges. Okay. Now we come to the types of plates. So plate boundaries. We have three types of plate boundaries. The first type is called divergent, which means they travel away from each other. Usually you find that at mid-oceanic ridge, MOR, spreading centers and continental drifts. We can find earthquake and basaltic volcanism in these areas. Also, the second type called transform plate boundary, and plates here slide past one another, and we find a lot of earthquakes. Example, San Andreas Fault in California, United States. And the third type is called convergent. Plate comes together. There are three types here. First type called ocean continent. Second is ocean. And third one is called continent. Okay, let's talk about each one in brief now. First one, ocean continent. So oceanic lithosphere subducted beneath continental lithosphere. It goes underneath the continental. Why? Because the ocean or oceanic plate is denser. The density is high here for the ocean. That's why it sinks down or underneath the continent. Okay, many earthquakes and andesitic rhyolitic volcanoes happens here. Examples are Andes and Cascades, and please keep those examples in mind. Ocean, yeah, so the cold, denser oceanic lithosphere subducted beneath the younger one, the older one, subducted beneath the younger one, which is still hot, and therefore less dense oceanic lithosphere. And good examples of this is Mariana's Trench. The last type here is a continent. There is little or no subduction of low density continental lithosphere. They have low density. And usually only you find an earthquakes in this area. And good examples of mountains that represent continent plate boundaries are Himalayas mountains. Okay, so this was just a brief about the plate tectonics theory, and I thank you, all of you. Please review your lectures, and if you have any questions, you contact me, and don't hesitate to call me anytime. And thank you, and you have a wonderful day. Bye.